All right, thank you for joining back in. And I made a separate video because I'm going to chunk now the main idea, the theory that we did in class in that last video to the distance formula. We're going to actually build that formula that was at the end of the last video. All right, so give me about, I don't know, 1 or 2 minutes. Stupid school bell. Before I actually write the formula, but I'm going to put the formula in a box and highlight it at the end of this. But here's the theory that I think is more important. So we have a point. Who knows what it is? We can put it on the coordinate plane. We have another point over here. Who knows what it is? But I do know the following. There's an X and a Y. Oops. And a Y to this point, right? Over at this point, there's an X and a Y. So I'll call it X2, Y2. And that first point I'll call X1, Y1. So again, just think these are 2 points. Who the heck knows what they are? They can change. They can vary. We need to find the distance between them. Boom. This is our goal. What is the theory? We imagine drawing a right triangle. Actually, we haven't been imagining it. We've been doing it. We've been actually doing it up to this point. And I'm still doing it right now. All right, let me erase some of the overflow here. Good enough. All right. And in a right triangle, we call these the legs. And we know that the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Great. I'm going to ditch the word legs and hypotenuse for a few minutes because we're talking about this is what we crave, distance. This is what we want. And if you've been paying attention, we can associate this bottom leg, the base leg, if you will, as run. And we can associate the other leg, the up and down leg, as the rise. Words that we use in Algebra 1. So it's nice to kind of build on that. So we have rise and run. All right. So for a moment, if I just focus in on this right triangle, leg squared plus leg squared equals hypotenuse squared. Let's change the words from legs and hypotenuse to what we see. We can write run squared plus rise squared is equal to distance squared. That's literally the Pythagorean theorem, just not using the words leg and hypotenuse, using what's in our diagram. Now, what do we do every single time we take the square root as our last step, right? So you remember in the previous videos, when we're all done, I take a square root of both sides because we want to ditch that exponent of 2. So let's do that right now. If we take a square root of both sides, this exponent right here cancels out. I'll zoom in on it. If we were to take a square root, and what would remain is just distance, which is actually what we want. Remember, that's our exact value. Now let's do something else. How do we calculate run? How do we actually get the number value for for run? We know from algebra, we know from our practice that run is x2 minus x1. So I'm replacing the word run with its little like sub formula. And how do we find the rise? Very similarly, we replace it with y2 minus y1 squared. And my wonderful, amazing students, what we are looking at right here is what is called the distance formula. This right here, if you Google search it, if you watch Khan Academy videos, if you know that is, if you have, whoops, there's a train going by. Choo-choo. All right, all kidding aside, if you look this up online, if you look at a textbook, go to a future class, this is what you're going to see. Man, that looks intimidating. But you guys are amazing because you followed the explanation of that. Not every student gets that explanation. It's literally the Pythagorean theorem, rise and run. Wonderful. Okay. This is the formula. Let's apply it. Let's apply it. Do you remember in the last video you watched a couple minutes ago from Delta Math, the example? Actually, I can go right back to it. It was right here. We worked it out. I'm going to do this now without working out a diagram. I'm going to do it just applying the formula. -8, 6, and -6, 0. So same question, but no diagrams. No diagrams, just formula based. And honestly, I don't know if you can see my facial expression. I get sad with this. Like, formulas are awesome. They're cool. They're shortcuts in a way. But in this particular skill, I actually love the diagrams because I love when maths connect with each other. We're using algebra. We're using middle school Pythagorean theorem. We're using some geometry, and we're building like really cool big theorems. To me, that's exciting. A formula, you know, I can go up to the person on the street and say, here's the formula, and there's none of that there. It's not any connection. It's so blah to me. It's so boring. But formulas aren't, I'm not saying formulas stink, right? They just kind of take away from, I don't know, the enjoyment of what I love about math. But I'm going to try to keep this video short. All right, so in this way, no diagrams, just formula based. The distance between these 2 points, I'm going to write the formula. In my mind, though, I know better. I know where the formula comes from. It's run, which is x2 minus x1, plus rise, which is y2 minus y1 squared. All right, so it's really the Pythagorean theorem in disguise. We're going to substitute in the values. X2 is -8. I think I have something wrong here. Isn't it -6? Yes. Let me go back just to show you. I wrote that wrong. But the example was -6, 0 right there, right? Okay. So X2 is -6 minus -8. We got to square that. Plus y2 is 0 minus 6 and square that. So there's the formula. There's the substitution. And now order of operations tell me to work inside my parentheses first. So I need to find this value and this value as my next step. So I write the formula, I substitute. Now I follow order of operations. -6 minus a -8, keep change. I'll even mark that right here, keep change. This becomes the value 2. So inside the group, it simplifies to 2. Inside the second group, 0 minus 6 is a -6. Order of operation now tell us to do the exponent. 2 squared is 4. -6 squared is 36. Order of operations tells us to combine that to 40. And there's our exact answer, which we use a calculator to approximate it. I forgot what it was. I want to say 6.2. Is that what we saw before? 6.3. But yeah, you know, you can see we get 6.3 as our approximate answer. And that's the distance formula. Apply the formula on the next set of questions, and I'll see everyone tomorrow. Can't wait. You guys are doing amazing. All right, end this video.